Here, 11, today we're looking at application type questions, and specifically where we go from a function that has been differentiated, and then they ask us questions where we have to use the original function. So this is also known as the total change theorem. So they give you the rate or the differentiation function, and you calculate the total by integrating the function. All right, so let's have a look at word example 1. The rate of flow of the water into a tank is given by this function. Now have a good look at this over here. It's dv over dt. So this was originally a function, v, in terms of t, where you could calculate the volume of the water at any time t. This has now been differentiated to dv on dt. So in other words, it gives you the rate of flow of the water, not the volume at a certain time, but the rate of flow of water. And they also give you a domain 0 to 5, and then they define V. V is liters. It's the amount of water in the tank at time t minutes. Then they also tell you if the tank is initially empty. So straight away you can think, well, if the tank is initially empty means that there's nothing in it, and initially time 0, V equals 0, time equals 0. And you're probably starting to make connections now. A little light bulb switches on. You probably go, oh, maybe this I need for my plus C to calculate. So we'll talk about that more. And then the question is, how much water in the tank? How much water in the tank? In other words, what's the volume of water in the tank when the water flow is 1 liter per minute? How much water in the tank? So to find the water in the tank, what are you going to need? You're going to need this function over here that gives you the volume at any particular time. All right, so that's what you need. At this stage, all you know is that the flow of water is 1 liter per minute. So this flow of water, you're going to use this information to find the time so that you can substitute that time into your volume function to find the volume. So, but let's just go through the solution now. All right, how much water, if the water flow is 1 liter per minute, is 1. In other words, this function that got given over here, the derivative function dv on dt, what do I know? I know that my water flow, I know that my left-hand side is equal to 1. That's a flow of the water is equal to 1. So 1 is equal to my right-hand side. Now you're in a position actually to find the time when the water flow is 1. Remember, you've got your calculator. So 2 ways of doing this. You can go straight into solving, type that in and find your time, and then check your unit. Say go back to the question. Time was defined as minutes, so it's minutes. Or the other option is to go to graph mode, type in your function there. You know your y value, you know the y value is 1, so the rate of flow of water is 1. And you can go gsolve, find x calc over here, and it will give you the time value there. So you've got 2 options. You can do it graph mode, or you can do it in run matrix mode. All right, so now you have the time. Now that you've got the time, you can use that to find the volume of water. But what do you have to do to that function you got given? You've got to integrate it. You've got to integrate it. So to find the total volume of water, you've got to integrate that dv on dt. And now you are going to use your time values. You're going to say the lower bound is 0, so I start at 0 minutes. And I'll want the volume when the rate of flow is 2.2969. And this is called the total change theorem. So you can just go straight into your calculator, type that in, lower bound, upper bound, your function that you're going to integrate, and it will give you the answer in liters. Okay, so have a good look at this one, all done in your calculator. I just want to go back to this information over here. So because it's tech active, you didn't have to go through that process of finding the plus C, all right, because you're using your calculator to type in that function. You're giving it a lower bound and an upper bound. So really, really good question. Please pause the video and make sure you go through this step by step and slow down with your calculator work. The second worked example is also tech active. This was actually in one of the QCAA practice papers. So let's have a look. During one 30-day period, the rate, so all of these keywords need to pop out of the page. 30-day period, the rate at which pollution passes into a nearby lake is measured every 6 days, and the results are given in the table below. All right, so there's every 6 days, and it gives me the rate of pollution in units per day, the rate of pollution. Then it tells you that this information can be modeled as a quadratic function, so that's good to know. And then the question is, determine the total amount of pollution entering the lake during this 30-day period, the total amount of pollution. So what you have to understand is that the total amount of pollution will be the integral of this rate function over here, so this quadratic function. So you're going to use your calculator, you're going to find that quadratic function, you're going to integrate that quadratic function to find the function that you can use to find the total amount of pollution. And then your bounds will be, it gives you a 30-day period. So the first day is 0 and then up to 30. So all you really have to do is find this quadratic function. So you've got the data in a table. Now, if you can't remember from year 10 and early on in year 11, we have done it. And if you go to this video over here, they take you through the solution as well. At 8.50 minutes, you can find how to do that in your calculator. Go to stats mode, type in your data, go regression, pick x squared for your quadratic, and then your calculator will give you this function, this quadratic function. All right, so there's 1 mark for getting the correct model. So all done using your calculator. Then you need to understand, to find the total amount of pollution, you need to integrate this function. And you've got to put in a lower bound and an upper bound, the 0, 30. So it says provide statement identifying use of definite integral. And then you just type that into your calculator and you get your answer 373. So again, it relies very heavily on your calculator skills. So please make sure you understand the theory behind this and then practice on your calculator. And here are 2 homework questions. The first one is from an exam paper, Tech Active. And then question 2, another Tech Active one from your exam revision booklet, question 5 and paper 3A, that are really good. So please check in with me and I'll see you at tutorials.